Hello everyone, and we have to perform fine tuning of Llama model. In yesterday's, I have discussed in detail about large language models, and I also talked about the techniques which are used in Llama. However, not every organization is going to tell in detail what kind of architecture they have used. However, few concepts like that means the good ones which should be noted: supervised fine tuning, reinforcement learning, parameter efficient fine tuning. These are some terms which are being taken in the official document also of Llama. They told we have applied these techniques to improve the model from Llama 2 to Llama 3. We have also increased the size of the tokens. So now you are getting the good size of the inputs. You can give huge document also as an input that can be tokenized up to like 4096 to 8000 something. Okay. And then they also told this is open source. That's one of the important thing. The best thing is the model is open source model, and that can be used for your work. Before that, I have also shown you the official website where you have to register first, and then you should able to use the model after getting the permission from Meta. Okay, fine. So in fine tuning, what we do is we are available with model, that is your LLM, large language model, and you have to now prepare this model for downstream task. Okay, this model is already having a knowledge of text. In Llama, they told 30 languages are covered in Llama 3. Okay, and the vocab size is also huge. So we are not limited in this model. We are having so much capability. Vocabulary is also very vast. Token size is also more. Languages also it know more, and it is having some good techniques which they mentioned in their template, in their documentation. They did compared it with the other models. They told that we are good in performing maths, we are good in performing reasoning, and we are good in the general knowledge, we are good in physics, bio. So that's what they have mentioned. Okay, you want to fine tune your model. That means you want to turn up your model for a specific task or downstream task. Okay. So this fine tuning, as I told yesterday also, that you can either fine tune the entire model, or either you can fine tune few layers which will be convenient for us at the moment. Okay, because we are having the resources which are limited. Okay, so just fine tune some of the layers. Parameter efficient fine tuning. Okay, PEFT we will be doing. In this, we are having LORA, low rank adaptation. Okay, low rank adaptive technique. So that's also we are having, because ultimately what you have to do, tuning means, okay, what's we are going to do in LLM or whatever, you are creating neural network, you are having layers, you are having neurons on the layers, and tuning means, okay, you have to adjust the weight. Okay, adjust weights. That's what you do in training or learning. Parameter adjustment is what learning only. Okay, so in neural network, that's what you want to do. Fine. And we are implementing this today. Okay, so now I am sharing you the code, and let's see what's present in it. All right. So here is my code for fine tuning of Llama 3 based over sentiment analysis. Okay, I'm going to perform the sentiment analysis, the fine tuning of Llama 3 model. This data set is based upon financial news, and I will be using this data set. I will be training my model over this data set. Okay, so if you want to check, fine. I guess, okay, here. First thing, if you edit my code, edit my notebook, here is the edit option. Once you edit this notebook, you will be seeing Llama 3 8B. Okay, Llama 3 8B. Yesterday also I told that these models are low, medium, high range, different types of models. So it means how many number of parameters they were trained on. So 8 billion, 80 billion. We have seen yesterday Llama 3.1, more than 400 billion. So that's a huge model. I am using here base model. So if it's been written like this, Llama 38B, B means base, basic model you are using, lightweight model you are using. So I have added that only. And first I took the permission. If you are not permitted or not having the permission, you can't access the model. And for permission, I already told in the yesterday recording, the website is there, Meta official website, is there. Their download option is present. Okay, in download option you can click on the download, you will get the range of models. You click on any of the model, fill the details, name, your email address, everything, just fill it. And you have to wait for some time. And hopefully over this, if you have created your Kaggle account on the same email address which you are putting there, okay, so after some time you will get the access, and then you can add sentiment analysis data. That's not a very tough job, that's a very easy. The only thing is adding the model. Okay, so I have added the model here, and in Kaggle there is an option add model, so you can select Llama, and it's already present in my notebook. Okay, and sentiment analysis on financial and economic information. Okay, there is some theoretical part mentioned here. Okay, like for business purpose, reasoning, and everything, like marketing. So sentiment analysis we are going to do on a financial data. Okay, so it's not mandatory here to read each and every line. The details are mentioned in the code book. The first step which you are going to perform is we have to add the libraries, because they only provide the support to perform the further implementation. Okay, and the framework which I am going to use here is the PyTorch. Okay, that is the meta framework. So this PyTorch, na, it is open source machine learning framework developed by again Facebook only. So model is also of Facebook, and the framework is also of the Facebook. Okay, it can perform a lot of tasks. It can perform dynamic computation graph. Okay, it uses dynamic computation graph. It provides more flexibility by using this thing. Okay, tensor, it operates on tensor, that means high dimensional data. It can effectively use the GPUs. Okay, it has been question asked to me, sir, TensorFlow versus PyTorch. So the thing is, we have to use the GPU effectively, and PyTorch is a framework which can help us in the better way. Okay, fine. So that's what it is important. Then in PyTorch, we are having automatic differentiation. See, grades, gradient. Okay, we calculate weights. W dash is equal to W minus alpha del L by del W. So automatic gradient calculation is also there in the PyTorch. Okay, it's based upon neural network module. So we are having torch.nn here in the library in this framework. So it is having so many flexibilities. Okay, then transformers, I did taught in my class, in my Gen AI class also, that here it is mentioned the transformers. Okay, so it's a library for natural language processing. So transformer, you can get the details from Hugging Face official website also. And this transformer is a breakthrough in in many things, whether you can talk about text, whether you can talk about images. Okay, this architecture, transformer architecture, is based upon encoder and decoder. So encoder and decoder is the game changing. Okay, so transformers can perform, your GPT is also a transformer, generative pre-trained transformer. Okay, it can perform many tasks: language translation, classification, question answering, machine translate. Many things are there in the transformer. That's what you can do. Okay, and we are having some other libraries that's also mentioned here. Accelerate library is there. It's present in PyTorch. It allows to train the model on multiple GPUs. I need to accelerate. See, this is a heavy model. Doesn't mean that you are taking Llama 8B, so it's easy. No, 8 billion parameters are also not easy job. Okay, so we can accelerate, speed up the process, speed up the training process. So accelerator library is there. PFT, parameter efficient fine tuning, we are having. So in this parameter efficient fine tuning, what we can do is various downstream applications, without fine tuning all the model parameters, we can. That's what I told initially. You have to pre-train your, matlab, you are using pre-trained model, and you have to fine tune it. So भैया पूरे मॉडल को तो ट्रेनिंग ना करो, बड़ा है वो, it will take a lot of time to train the entire model. We are using this PEFT technique, parameter efficient fine tuning technique. That means it will train the, or it will change, or it will tune the neurons weights which are present in the outer layers of the architecture. We are not going to touch the entire architecture. Okay, in fine tuning we don't do this thing. Fine. So without fine tuning all the model parameter, it is better to fine tune on a small, just change the weights of few model parameters, that's it. So decrease the computational complexity, and storage cost also we are reducing. So in our task, like just sentiment analysis, so sentiment analysis is not a big deal. Okay, so we are using PEFT, bits and the bytes. Okay, see, bits and bytes, it is a lightweight wrapper around CUDA custom functions. Like, okay, 8-bit optimizer, we need to perform maths. We need to perform maths. Maths means, okay, you have to perform matrix multiplication, matrix addition, matrix subtraction, matrix division. Okay, there are many things. Especially matrix multiplication is something which has been done in the architecture, in the model. Okay, we are having weights, we are having bias, we are having inputs, so we have to multiply them. Okay, and for multiplication also, for performing this mathematical operation also, we have to quantize. Quantize means, in particular, there are 8-bit optimizers. We have to run the models on 4-bit precision. Therefore, 4-bit and bytes storage weights in 4 bits. The computation still happens in 16 and 32-bit. Here are the combination can be chosen. That means, okay, if you are having 8-bit optimizer, you can now convert them into 4-bit precision, and then you can perform the multiplication. It's saying that you are having the information, you are having the details, the data, you are having the vector representation. Okay, then you have to minimize the computational complexity. For that, don't take the entire bits, 8 bit, 16 bit, 32-bit. It's better you can quantize, okay, into small. So perform the quantization. So this bit and the bytes are used to perform the quantization. Okay, got it. Very important, because you are dealing with a huge model, and in huge model we are having so many computations, and in so many computations it will take a lot of time. It's better simplify, use 4-bit representation instead of 8-bit representation. Got it. So internally it will do this task. Okay. TRL, we are having one more library. It's a full stack library of Hugging Face, a set of tools to train transformer language models with reinforcement learning. See, in the yesterday class only I explained, no? Supervised fine tuning, the RM proximity PP optimization. That is your feedback. Okay, we need to take the feedback, no, from the humans, whether the output generated by the model is good or not. Okay, so these things are covered in the previous lecture. So this TRL library is going to help you for that. Okay, got it. These are certain libraries which I did installed first, which provides the support to the model. Okay, with, see, this model they already told they have used these techniques. Obviously, the model is also based upon transformer architecture, but they will not let you know how many layers, what kind of attention mechanism. No, they will not let you know entirely. Okay, basic transformer we know, over based over which the GPT is built. Okay, you can also prepare the same architecture from the scratch for the GPT. You can do that, but there are still many mechanism engineering has been involved. Okay, so whatever they told in their documentation, explain. Here are the libraries which I imported. Accelerate, Dataset, TRL, PEFT. TensorBoard is for documenting the training and what the results we are getting. So that's why it's used. Okay, so Torch, Bits and the Bytes, Transformer, Accelerate, Dataset, TRL, PEFT, all this I've installed. After installing this thing, okay, just give an environment. Okay, so you have to give an environment for the code to run properly. So we are setting two environment variables, CUDA visible devices and parallelism. Okay, so the environment variable tells, this environment variable tells PyTorch with the GPU. Okay, CUDA visible. CUDA, okay, that's a GPU, no? So it tells whether the GPUs are available, and if they are available, then you can use it. And obviously, without GPU, we can't work on this particular code or the project. Okay, it will take 1 week to train on a single EPO if you don't work over the GPU. Okay, got it. We are taking parallelism also. That means transformer library where parallelize the tokenization process. Okay, so for that for tokenization, you give the input that will be converted into tokens. Okay, so this token process now we are performing in parallel way. So for that we have set up the environment. Okay, import OS, and this is the environment we have set up. Okay, so CUDA devices is 0, parallelism is false. That means we are not doing the parallelism here. So let's set it false. Okay, fine. And CUDA devices, here it is set to be as 0. We can have the values like 0 or 1. Though I am using the GPU here, so 0 may be like something. We are using the GPU which is present at the first index position. Here I have, okay, if I use like GPU T4, 2. Okay, 2 GPUs if I use, so it can be like the first GPU can be utilized for your purpose. Warning you very well know. Then these are the basic libraries. Okay, these are the basic libraries which I have imported. Okay, like NumPy, Pandas, TQDM, bits and bytes, Torch, neural network, transformer, dataset, everything, TFT, everything I have used here. And then we are having this TRL, SFTT trainer. Okay, TRL I already explained you about to take the feedback from the, okay, to take the feedback, reinforcement learning, also for the optimization. TRL I already explained you about. Okay, that means this reward modeling, supervised fine tuning, supervised fine tuning, PPO, proximal policy optimization, everything has been present in the TRL. Okay, so here I am importing the TRL, and then many things from the TRL, like the trainer, I am taking from the TRL, setup chat format. Okay, that's not the important thing which we have to concern about. In PEFT, we are taking LORA configuration and PEFT configuration. That means parameter efficient fine tuning and low rank adaptation technique. These two we are taking just to train the few weights, few neurons present in my architecture. That's what I'm going to do here. Okay, got it. And then transformer, I am just taking this auto model for causal LLM. Auto tokenizer, bits and bytes configuration, training arguments, pipelining, logging. Okay, that's what I am taking. So what they mean? Okay, I want to explain you about the transformer here. What actually they mean? Auto causal and the rest, what the parameters we have used here. So this should be known for our purpose. Okay, fine. So here this parameters from transformers, import auto model for causal LM. See, auto model, what it means is automatically, okay, it's automatically loading pre-trained model. That's what it's called. Auto model for causal LM. That means automatically load pre-trained model for causal language modeling. Okay, automatically load the pre-trained model. Right now, I haven't mentioned which pre-trained model I'm using. Obviously, I'm going to use Llama 3. Uh, okay, that's what my target model is. So, in order to load that model, automatically load that model, I am using this parameter auto model for causal language modeling. Automatically load the model. Auto tokenizer, what is this auto tokenizer means it can perform the tokenization automatically. So wherever you are seeing the word auto, so loading the model automatically, performing the tokenization automatically, bits and the bytes, I already told you, it can configure your model. Okay, it can configure your model, and it can perform the matrix multiplication or mathematical computations in low digit representation. That means it can be 4 digits or something like that. Okay, we are just mentioning 4 bits. Okay, then we are having the training arguments also. Okay, so what training arguments, whatever we are going to use here for as a training arguments, will mention while training our model. That will mention. Pipelining also here I am mentioning. Okay, so it will create the pipeline for various tasks like text generation. Okay, so from tokenization, then there will be vocab generation, then vector generation, then attention mechanism, then after attention we have to perform again the embedding, then normalization. Then there are many things happens, okay, during your training process. Okay, so there is a pipelining created. Login means to log in into the transformer library. Okay, that's what the login means. Okay, so auto model, we are using auto model is a term used in machine learning that can be automatically generated or trained. Okay, automatically generated or trained. So that's the reason we are using auto ML. Okay, got it. So here I am taking auto model for causal language model. Okay, and then these are the basic things which you very well know. SQL metrics accuracy and all you very well know. Okay, fine. So this much task I have done. I checked my PyTorch version 2.1.2. Okay, I am using GPU. Okay, GPU CUDA 0. Okay, I am having two GPU. So one is present at 0 memory, one is present at 1 memory. I am using CUDA 0. That means the first GPU. On this device I will work. If the GPU is not available, then you have to work on CPU. Okay, so that will not the case. So we can't work on the CPU. Okay, and then what we are having? Torch.backends.CUDA enable memory efficient SDP false. Torch backend.CUDA enable flash SDP false. Okay, SDP. See this, we are here disabling two features in the PyTorch that are related to memory efficiency and speed during graphic processing unit for scaled dot product attention function. Again, attention mechanism. Okay, at this particular time for the model we are performing the fine tuning, we are not using, we are disabling these two features which are related to memory efficiency and speed. Okay, fine. So that's what been performed here in the code. Okay, so torch backend CUDA enable. CUDA means GPU. GPU is enable. You have to use graphical processing unit. Okay, so during graphical processing unit, the computations are done, the operations are performed, and there the operations will be like scaled dot product attention. This operation will be performed. By default, by default, PyTorch may use memory efficient strategies to certain operations to optimize GPU performance. Okay. However, I have disabled this feature here. because I want to increase memory usage. Okay, just in by case default, it's not mandatory. You can perform true also. Okay, you can do true also, but I just highlighted this thing. Okay, so memory and the speed. One is your memory efficient SDP, another is flash SDP, which you are using. So again, this is for the next one, flash SDP. This is used for optimizing the speed. Okay, this one, flash SDP. This is used for optimizing the speed of scaled dot product attention mechanism. Okay, it can provide some accelerations. Okay, to optimize the operations which are performed for SDP for scaled dot product. Okay, so in this case we have disabled actually. Okay, fine. And then the next is I am taking my dataset, sentiment analysis for financial news. Okay, and here I am having, hey Resham चिल्लाया मत. Here I am having what? Sentiment and the text. These two columns. Encoding UTF-8, that's it. This is my data frame. This is the news and this is the sentiment. Neutral, positive, negative. Okay, so data frame I am having. I need to fine tune my model over this data only. I can print the shape 4846. These are the columns, sentiment and the text. There are six duplicates present in my data. I will drop them. Okay, so drop duplicates. Drop the six duplicates. There are no null values present in my data. Okay, then df.info, just print the information, print how many unique values are there. Okay, three sentiment, these are the unique values present. Okay, you can make a count plot for it. This is unbalanced data. Okay, you can make the count plot for it, and you can make the pie plot for it also. Count plot, and so this is a general coding or a general programming. Here no special technique I have used. Okay, nothing I have used specially, it's just a general technique. All right, fine. So let me share my white template again to explain you what we have followed so far. Let me explain you again. Okay, so here is the screen. Now listen to me carefully because this is very important project and that's about the fine tuning of a model. You want to fine tune Llama 3, large language model, already pre-trained model. Okay, pre-trained model on huge amount of text. Okay, fine tuning you want to do with the sentiment data. Okay, that's what you want to do. Okay, so you are having model, you will take a data which is having text and a sentiment, and you will be having a new model which can perform sentiment analysis. That's it. Okay, so the model, what we are using here, some libraries like what we are using, TRL, then we are using PEFT, LORA. These are the libraries we are using. This is for optimization, reinforcement learning. This is for changing, adjusting the weights of your large language model, but for few layers, not the entire model, just few layers. Okay, that's what we are using. Okay, we have enabled GPU, Okay, we are setting up the environment. Okay, we made few things false. Okay, that means related to memory efficiency, related to speed. We made the things false, we can make them true also. If you make them true, definitely your Llama model will perform better or quick. Okay, that will be using effectively your memory and computation capability. Okay, they can perform. And the more important thing is SDP, scaled dot product. Okay, scaled dot product. Definitely. We are using one more thing. Okay, bit and bytes. That's what we are using. Bit and the bytes. Okay, bit and the bytes will convert the things into 4 bits because you want to perform matrix multiplication, and it's not only one matrix multiplication, not two. There are many matrix multiplication needs to be done. These guys haven't told, sir, Llama architecture. Okay, they haven't told how much big it is, what component exactly they do have, how many layers. They just told, okay, 8 billion parameter, 80 billion parameter. It can be more also. In 3.1, it is more. In 3.2, they made the things lightweight. But in 3.1, we have seen more than 400 bytes, not billions of parameters, more than 400. Okay, so to perform effective computation, bits and the bytes are used. Okay, and then you took your data, sentiment data, you prepare the data frame, you made the your count plot and the pie plot, and by seeing that data it's quite clear that it's looking unbalanced. Currently you are having unbalanced data. Okay, but actually, I'm not balancing the data here. But you can, when you are getting this code now, and when you are going to perform the task on this code, you kindly do the balancing from your side. Okay, you can balance the code from your side. Okay, that means data. Fine. And then what happens next? Let me again share you the screen for the code. Okay. Now let's again get back to the code. What we are doing here. See, here now we have to create your X train. This is an empty list. X test. This is an empty list. For sentiment in positive, negative, and the neutral, train test. Okay, I am making training data and testing data. Okay, that's what I am taking. Train size I am taking 400. Test size I am taking 200. Okay, so for positive, take 400 values and 200 values for testing. Okay, for each and every category do this thing. For positive, take 400 training, 200 testing. For neutral, take 400 training, 200 testing. For negative, take 400 training and 200 testing. See, you can perform train test split from your side also. That's not mandatory that you will be using my technique only, not at all. It's not mandatory. You can choose your technique also to perform train test split. Okay, you can split your data. You're already having the data frame now, so you very well know how to use train test split. Make X. Okay, you are having X text now, you are having. Okay, and the target is your Y, that is the sentiment. Okay, so X and Y you are having. Then perform train test split x comma y, stratify equal to y, random state equal to 42. That's it. Use this technique. Okay, it's not mandatory that you are going to apply my set of code. Okay, but here I just use a technique to perform the train test split. You can use your approach also. Fine. So the complete explanation of what I did in the code has been mentioned here. I am using xtrain and the xtest as empty list. I perform the iteration over the sentiment category. I use train test split as a function. For each train and test, I'm using 400 and the 200 samples. That's what I'm using. Okay, don't go with this. What I told is the correct thing. Okay, and then I fixed the splitting by a random state 42. You very well know the random state 42 keeps importance. Okay, and then I appended the train and the test data. I perform the concatenation of the train and the test set for all the sentiment. Okay, so train, okay, positive, negative, neutral, 400, 400, 400. Test, positive, negative, neutral, 200, 200, 200. And then I prepared evaluation data also by sampling 50 samples from the sentiment category, per sentiment category. That's what I did. Okay, so what's the purpose? You very well know what the purpose is. Why we perform train test split? We'll train the data by training, and we'll evaluate our data during training only using evaluation. And once your model is trained, then you can use the test data. That's it. So that's the logic. And then here I'm keeping a template. Okay, this is a template. Generate prompt. Analyze the sentiment of the news headline enclosed in the square bracket. Determine if it is positive, neutral, or negative, and return the answer. And here you have to mention the text. So before mentioning the text, you are writing a line from your side. So this is a custom prompt which you are giving. Okay. So custom prompt. Fine. Analyze the sentiment. Okay, it's same only. Okay, so it's been mentioned two times. It's just like same only. This is for text, and yeah, here I'm mentioning the text and the sentiment. Okay, so what it is doing again, we are making a function to generate a prompt for sentiment analysis. It will take the text and the sentiment. The first one, this one, it will take the text and the sentiment. This function will create a prompt. Okay, this prompt will ask to analyze the sentiment of news headline. It embeds the news headline and sentiment from the data point dictionary in the prompt string. Dot strip is to remove the this white spaces in starting and the ending of the sentence. So that's why strip is used. And in the next, we are going to generate a prompt for testing sentiment analysis based upon a data point or based upon a value. Same thing has been mentioned here, but this is for test. Okay, and this is we are here we are using, in this particular case we are making a prompt for sentiment analysis based on the given data by including the text and the sentiment both. Okay, fine. Then I just prepared a data frame: x train, x evaluation, x test. That's what the data frame I created. And from here I made training data and the evaluation data. Okay, so this particular code is used to generate prompt function for each row in the training data. Okay, so generate prompt for each row in the training data. Okay, in train also, evaluation also, and test also. Create data frame, predict the label, and then create the data set. It will convert the pandas data frame into data set because we do use data sets. Okay, so data set is a compatible with Hugging Face dataset library. That's why we are converting a data frame into data set. So data set will be used to load into the model for your training purpose and evaluation purpose also. We can use these data sets to be put in the training model. Okay, fine, got it. So again, let me get back to the sheet and help you in understanding what we did so far. Okay, got it. Actually, at the moment we are playing with the data, and we are performing the pre-processing of this data to be ready put into the model. Okay, let me explain you here. See, you very well know that we have imported the libraries in support of the model. We have imported the data frame, which is having text and the sentiment. That's what it is having. I need to fine tune my model with this data only. Okay, fine. Then you splitted your data into training and testing and your evaluation. Evaluation. So train, test, split. You did. Okay, so training data, testing data, and validation data. You can do it in an easy way also. What we have seen in the data frame is you are having like 4,800 something rows. You are having three sentiment categories. You can do one thing: x equal to df text, y equal to df sentiment. You can write train, test, split x, comma y, comma, here you can write stratify equal to y, random state equal to 42. That's what you can do. Okay, and you can mention what is the training size. Okay, 80% training size you can mention. Okay, train equal to 0.8. That's what you can mention. So 80% will be the training data, 20% will be the testing data. Then from testing data also, again you can again split the testing data into, again you can use train, test, split. You can use the test data, okay, test data, to divide it into 10% validation and 10% test. That's also you can do. Okay, fine. So this is the basic code which you can apply rather than the code which I have used. I took there, okay, 400 for training, 400 for testing. Okay, not for testing. 200 for testing. 200 for testing. Like this, I have taken the data. So 400 training each category: positive, negative, neutral, and 200 for testing each: positive, negative, neutral. That's what I have taken. So it's not mandatory that you will follow my step. Not mandatory. You can go ahead with this. And after creating this train and all this, okay, what I did next, I converted this, because obviously when you perform train test split, and then you will check how x train looks like, whether it is a data frame now or not. It's not a data frame. It's not a data frame. Convert this thing into data frame by using pd, okay, dot to data frame. And then after converting this into data frame, convert it into data sets. That's what I have done in the code so far. Nothing else. I am already available with the data, but I haven't applied any of the NLP data cleaning technique. No. You may ask a question, sir, you are having a raw data, sir. You are having text, you are having sentiment, sir. You are having a raw data. Sir, you haven't applied the cleaning of the text. हाँ, नहीं करा मैंने, ज़रूरत मुझे लगा नहीं, क्या करूँगा क्लीनिंग करके, वो तो आती है ना। वी हैव ऑलरेडी डन एनएलपी प्रोजेक्ट, अब क्या करूँगा क्लीनिंग करके। आप बोलोगे सर वो उसको लोअर केस में कन्वर्ट करो, देन स्टॉप वर्ड्स डू रिमूव, एंड देन परफॉर्म लेमेटाइजेशन, देन पंक्चुएशन मार्क्स रिमूव, एंड देन देर आर मेनी थिंग्स, हाइपर लिंक। नो नो, आई हैवंट डन एनीथिंग, कुछ नहीं करा मैं, नो, नथिंग। Whatever be the data available with me, na, I am just fine tuning with that only. You can perform, no worry, this is a suggestion to you. You can apply all the NLP techniques, clean your data. I haven't applied the cleaning of the data, नहीं करा मैंने। तुम करते रहना, मेरा खास उद्देश्य फाइन ट्यूनिंग था, तो वही समझाऊंगा। ओके, सो आई एम जस्ट ऑन द टारगेट, आई नीड टू एक्सप्लेन यू द फाइन ट्यूनिंग, वो मैंने नहीं करा। क्लीनिंग आप क्लीनिंग कर लेना, और फिर वो क्लीन क्लीन जस्ट क्लीन वाला डेटा फ्रेम डीएफ ले लेना। और मैंने तो बैलेंसिंग ऑल्सो आई हैवंट डन। बैलेंसिंग आई हैवंट, you know that there are three classes, and we they are unbalanced. ओके, वो भी नहीं करा मैंने, ये भी आप करना। डेटा बैलेंसिंग, you can use random oversampling technique. And in the previous my projects, computer vision projects, I have used this technique, random oversampler. You can just copy the code from there, that's it। रैंडम ओवर सैम्पलर वो सब बराबर कर देगा। तो दीज आर द फ्यू थिंग्स विच वी यू कैन डू फ्रॉम योर साइड, डेटा क्लीनिंग एंड बैलेंसिंग द डेटा टारगेट। ओके, फाइन, डन। So far I have taught। Okay, now let's proceed to the next। Okay, let's proceed to the next, what is there in the code। All right, so again get back to the code, so here it is। Okay, so let me show you the code। All right, fine, so here is the code, and yeah, in this particular code, just map this positive, negative, and neutral with 0, 1, and 2। Okay, just map your labels, okay, positive, negative, neutral with 0, 1, and 2, that's what I have done। Not at all hard and fast coding, please don't go with my code only, no, not at all। Okay, I just perform the mapping, positive, okay, 2, neutral 1, negative and none is, like, negative is also 0 and none is 1, that's how you can। So neutral 1, none 1, if in case you are having none also, so it will be 1, neutral is also 1। These are the labels, and this is how you have to map। You can prepare a dictionary, that's it। तो ये डिक्शनरी तो है, डिक्शनरी से तो मैपिंग करिए। ओके, ठीक, तो मैप कर देंगे अपने डेटा को। And then I am using, once the model got trained, so I will be calling this method to print the accuracy, to print uh, to check, like, classification report, confusion matrix। So in you know about this thing right now, our problem is based upon classification, है ना। We are having three classes, positive, negative, and neutral। So you are performing multi classification। So again, I am just suggesting you, in case if you face any difficulty, though I have already mentioned the entire details here right now, okay, don't take the things as complicated, it's very easy। From data splitting, okay, from data splitting, creating train test split, converting them into data set, and then this thing also, okay, okay, it's not at all like complicated, it's very easy। Okay, fine. And then what I am going to use next is, here. Here is my model. Here is my model. Now I am taking my model. So far I haven't took my model. So far what I did is I imported the support libraries. I took the data set, and after that now I am taking the model 8B chat HF. This is a basic model, and HF is Hugging Face. Okay, fine. So it's a transformer model. So that's what its name, transformer 8B chat HF. Okay, so this is the model name, and I want to perform 16. Okay, float 16. Computation type will be float 16. Bit operations. I'm using configuration bit and the bytes. Load the data in 4 bits. No need to perform double quantization. This is your quantization type NF4, and this is how you are going to perform the computation. Compute D type. This is how you are going to perform the computation. All things is mentioned here. Everything is mentioned here. So this is my model name. I already used auto model for causal LM. Okay, so this is my pre-trained model. I will be loading my pre-trained model. Okay, that's what I will do. Maximum sequence length it can take is 2048. That's what I'm mentioning from my side. However, it is been known to you. Yesterday we have studied in the template. It can process 4096 also. You can increase the sequence length also, but don't increase the complexity. Let it be 2048. Okay, so sequence length I have mentioned. Fine. Then bit and the byte. We are configuring bit and the byte to perform quantization and optimization. We will load the weights in 4-bit precision. Double quantization we are not using. We are using this specific type of quantization, that is NF4. Okay, that's what we are using. All right. Then BNB 4-bit compute data type, that means it's specified data type for computation during quantization, so it is floating point. Okay, we have already mentioned in the code floating point data. Okay, get the attributes floating 16. So it will quantize this 16 into 4 bits. That's what it will do. Okay, it will quantize the data into 4 bits. Okay, so here I have taken, this is a type of quantization. This is the data type over which we want to perform the computation. Float 16. Okay, this is the data we will be taking, float 16. Okay, and then we'll quantize it into 4 bits with the help of bits and the bytes. That's what we will do. Okay, and the model we are using here is auto model causal LM. That's what we are using. Okay, and we will, by help of this, we will load the model, that is Llama 8B. We will load it. Okay, and then this is the sequence length. This is what you are going to perform the tokenization. Okay, everything I have mentioned here. Okay, got it. And then this is, once your model is trained, then we can perform the prediction using the model. We can give a text into the model, and this function can be called to perform the prediction. Okay, got it. So that's what mentioned here. If it results into positive, append positive, negative, append negative, neutral, then append neutral. Else none. Okay, fine. And this is the predictor function. Okay, so predict test model tokenizer. See why I am using this function here prior. You are already available with a language model, so you can give from your side only test data into the model, and you can ask for the prediction. Okay, you can ask for the prediction by your model, which is not right now trained for sentiment analysis. What you are doing here is you are this is the method to perform the prediction. Okay, and you called this method by giving your pre-trained model, but not on sentiment analysis. You give your test data to it, your model, and the tokenizer. Okay, it gave you the prediction. Okay, and when we evaluated the prediction which is given by the model, we found that the accuracy is only 32%. Only 32% is the accuracy. And label 0 is 0 only, nothing. Label 2 is just 0.015. That means it predicted label 1 more. So accuracy is just only 37% without performing pre-training of the model. Miss fine tuning of the model over pre-trained model. Okay, then what we have to do now, from here fine tuning starts. See, I tested my model prior, using the fine tuning prior to the fine tuning, just to see, okay, you are a pre-trained model, you are a huge model, let's see whether you can perform the sentiment analysis or not. The answer is like only 37% accuracy. Accuracy can also be increased, however, I have already given here unbalanced data. Also in my train test split I am not performing stratify. Okay, but I'm taking the equal proportionate by using the loop and everything. So might be we are giving the good proportion, equal proportion for each and every class. But however, what I found is my model is not giving good accuracy. Okay, we haven't fine tuned. No, just using the existing model to perform sentiment analysis. Existing model only using it, and then we have to perform the fine tuning. So what I am taking here is, okay, so this is the output directory where you are going to keep the train weights. This is the configuration file. Okay, LORA alpha 16, LORA dropout 0, rank 64. Okay, causal language model, bias, we are not giving anything. And these are some target modules we are giving. Okay, everything I have mentioned here. Target directory is a directory where train weights will be saved, log files will be saved. Training arguments, okay, I need to configure this parameter, that means the number of epos, batch size, optimizer, learning rate, logging option. These are your trainable arguments. PFT, you very well know, parameter efficient fine tuning. That's what we have to do. Okay, and then we are using SFTT trainer. This is for supervised fine tuning trainer. We want to perform supervised fine tuning of our model. We are having text, we are having sentiment, so this is supervised fine tuning. Okay, so I'm using this SFT trainer. We are having model llama 3 arguments, okay, which are defined earlier. Okay, arguments, they are already, these are the training arguments, these are the training arguments. Okay, so previously when I also teach in my Gen AI class, I just only talk about few things: number of epos, batch size, maybe optimizer, Adam W. Okay, so learning rate. This is the learning rate, but there are many. Okay, there are many other parameters. Okay, there are many other parameters. Fine. So, according to these parameters only, I am training my model. Like the other parameters are group by length, LR scheduler. Okay, there are many things. Floating point 16. Okay, then gradient accumulation, gradient checkpoint. Okay, there are many things. Okay, such details are available in my here template. Okay, remember, don't increase the batch size here. I guess the batch size is 1. Actually, what happened, I increased the batch size. Okay, it's like an issue. Okay, so we have to set the parameter accordingly. Also, gradient accumulation steps. After how many steps the gradient will be preserved, saved, because we need to perform backward back propagation. So gradient will be calculated, weight will be adjusted. W dash is equal to W minus alpha del L by del W. So okay, just keep this code as a reference. Okay, fine. And then I perform the training. Trainer dot train. I just trained for one EPO only. Okay, I can do for two EPO, three EPO. Here I put only one EPO. Number of times I've trained. It took a lot of time, yeah. It took a lot of time. Though I am using GPU also, na, it took a lot of time. So I thought that कि यहाँ पर बोल रहा है ना, ये अभी 18 मिनट्स बोल रहा है, 18 मिनट्स 54 सेकेंड्स फॉर फर्स्ट ईपो, ओनली वन ईपो। आई थॉट ठीक है, इतना बहुत है, लेट इट बी। आप चाहो तो उसको 2 या 3 कर देना, यहाँ पे यू कैन चेंज द नंबर ऑफ इटरेशंस, कम कर देना, बढ़ा देना, दैट्स व्हाट यू कैन डू। Okay, you can change the number of epos. Okay, fine. And then after training, I save the train model in the directory, and then these are the log details, what happened in the training. So that's not mandatory. And then I can perform the prediction by the trained model. This is fine-tuned model. Okay, this is fine-tuned model. And now you can see the accuracy 0.87. Previously, when I haven't performed the fine tuning of the model, the accuracy was 0.87, 0.3. Now it is 0.87. This is the accuracy which I am getting. Okay, fine. You can see with the class label 0, 1, and 2, this is the accuracy I am getting. Okay, fine. So that means with the fine tuning, now the prediction over test is being detected in a better way. Now my model is able to understand the downstream task. Now my model is able to understand the sentiment of the prediction, and when compared with the test data, I got a good score, 87. Don't expect 99 or 100% accuracy since you are using LLM. No, it's not like that. It's still a model. It's still an AI model. Though I got the balanced precision, recall, FN score, everything I got balanced. This is the accuracy which I have achieved. This is the confusion matrix. Okay, I can plot the confusion matrix also. That's not an issue. I can plot it. Okay, fine. So this is how you do perform the fine tuning of a large language model. And what you did in fine tuning, only this set of code, just only this set of code you have used for the fine tuning. Okay, this one. Okay, fine. And the trainer arguments, you have already mentioned what kind of training arguments, the main arguments which you require. Okay, like learning rate, your gradient optimizer, number of epos, number of gradients accumulated. So these are some things which you can use. Okay, and this is PFT configuration. This is additional in case of your Llama, because we want to optimize few layers only. Okay, that's what we want to do. Few layers only we have to optimize. Okay, fine. Okay, so that's what we have to do. So this is what the training is. And supervised fine tuning training we have performed by taking these parameters. Okay, fine. So this is how you can perform the fine tuning of your model. Okay, now let me share the entire screen. and let's again have a quick discussion based upon what we have done. Okay, so okay, how you can approach to approach a problem, this problem of fine tuning, you have to see which model you are using. Okay, which model? You're talking about Llama. So Llama do have its own architecture, its own dependencies. Okay, that's what we have seen. In regards to that, you have to install those dependencies. Okay, so yes, you are having TRL, you are having PEFT, you are having LORA, all these things you are having. Since it is a heavy model, so bits and bytes are required to perform the optimization, to perform the calculations in a minimum way, 4 bit. That's what you want. So my code tells about these things. Not in hard and fast. You can break the codes into three parts. Part number one is dependencies, libraries. Okay, you want to perform quick, so speed. If you want to optimize memory, so that option is also present. You can see in the code. Second is related to your data. You imported the data frame, you shown some plot that are not mandatory. What I told you is what you can do from your side: clean data, perform balancing of target. This you can do from your side. I'm making plus plus. You can do. I haven't done.
Sir,
Then you can, yes, yes, please say.
सर क्लीनिंग डेटा से क्या हम कॉन्टेक्स्ट कैन वी लूज कॉन्टेक्स्ट?
नहीं, देखिए क्या होता है ना, 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 देखो देवेश क्या है कि आपका सेंटिमेंट तो स्पेसिफिक वर्ड्स ही दे पाएंगे। स्टॉप वर्ड का सेंटिमेंट से क्या लेना देना, वो तो न्यूट्रल की तरह बिहेव करे। ओके, स्टॉप वर्ड्स आर नॉट बीन समथिंग विच कैन हेल्प यू असिस्ट यू इन अ सेंटिमेंट, पॉजिटिव, नेगेटिव और न्यूट्रल। ठीक है, देर आर सम वर्ड्स लाइक ओके, इफ आई से गुड, इफ आई से बेस्ट, ऐसा हम कुछ कहें। ठीक है, अब हमारा एक प्रीवियस डिस्कशन हुआ था, मुझे याद आया, आप उस कंटेक्स्ट में पूछ रहे हो, यू आर आस्किंग दैट कन। फॉर एग्जाम्पल, इफ आई से आई विल किल यू इन स्वीट वे। अब क्या होगा सर, आई स्टॉप वर्ड है, विल भी हटा दो सर, क्या लेना देना। तो किल, स्वीट, दीज टू वर्ड्स है। अब वो इन दोनों वर्ड से क्या करेगा, एक पोलैरिटी स्कोर निकालेगा, पोलैरिटी स्कोर इट विल कैलकुलेट। ठीक है, तो हो सकता है व्हेन दीज वर्ड्स आर देयर तो बेटर कंटेक्स्ट वो समझ जाए। आपका कहना सही है, मैं एग्री करता हूं। डेटा क्लीनिंग, डेटा क्लीनिंग, ओके, स्टॉप वर्ड्स डोंट रिमूव, मत करना। पंक्चुएशन यू कैन रिमूव, इमोजीज यू कैन रिमूव, और नहीं तो यार वो तो एलएलएम में, इमोजी भी मत रिमूव करो भाई। इमोजी भी यदि स्माइली होगा तो हो सकता है वो डिटेक्ट कर ले। आर यू गेटिंग माई पॉइंट? ठीक है देवेश, तो डेटा क्लीनिंग में यू हैव टू बी जस्ट कॉशियस। You can remove the digits, you can remove the punctuation marks, you can remove the hyperlink, but don't remove the stop word, don't remove the emoji, let it be, रहने दो उन्हें। ठीक है, ये आप कर लो, कोई इशू नहीं। हालांकि इन जनरल में तो हम स्टॉप वर्ड वगैरह रिमूव करते हैं एंड अप्रोच, बट लेट इट बी, रहने दो। नाउ वी आर डीलिंग विद हैवी मॉडल, एंड हैवी मॉडल को इस तरीके से कुछ सीक्वेंस हम दे दें तो बेटर समझ, कंटेक्स्ट पॉइंट ऑफ व्यू। ओके, कंटेक्स्ट पॉइंट ऑफ व्यू, ठीक है, मान गए आपकी बात। देन आई हैव डिवाइडेड माय डेटा इनटू ट्रेन टेस्ट स्प्लिट, ट्रेन टेस्ट स्प्लिट एडिट। उसका डेटा फ्रेम बनाया, डेटा फ्रेम का डेटा सेट बनाया, ठीक है, डेटा सेट बन गया, देन यू हैव लोडेड योर मॉडल. ओके, यू हैव लोडेड योर मॉडल बाय यूजिंग ऑटो एमएल कौशल, ऑटो, ठीक है, तो ऑटोमेटिकली इट कैन लोड योर मॉडल. You are having auto tokenizer also that can tokenize the data, tokenize the text. So ये तो कुछ कोड ब्लॉक्स है भाई, आपको you have to use as it is. अब मैं क्या बोलूँ इसमें, ये तो कोडिंग जो कई, ये जो स्टार्टर नोटबुक है उसका यूज़ कर रहा हूँ मैं. आई एम यूजिंग द स्टार्टर नोटबुक जो ऑलरेडी डिफाइन करी गई है कि ऐसे दिस इज हाउ यू हैव टू रन द लामा मॉडल, तो मैं उसका यूज़ कर रहा हूँ. सो यू कैन लोड द मॉडल्स. ठीक है, लोड कर दिया. उसके बाद देन द लास्ट वन इज ट्रेनिंग. तो ट्रेनिंग में आपने व्हाट यू डिड इन द ट्रेनिंग, आपने आर्ग्यूमेंट्स आर्ग्यूमेंट्स यू गेव, देन एस एफ टी, okay, sft trainer you are using, supervised fine tuning trainer you are using. Okay, you can see the code here, supervised fine tuning you are using. Okay, fine. So here the model is loaded, and then where it is? Okay, I think we do have no. Here it is. Load the model. Then this I have explained. No. Then what's next? Prediction. Okay. This is the fine tuning. This I wanted. ये रहा. So you can configure PEFT, parameter efficient fine tuning. These are your training arguments, and this is your training by using those arguments. Okay, so you have to define PEFT, parameter efficient fine tuning, and training arguments also, and use both of them here in SFTT. So model equal to Llama 3, training arguments already mentioned, training data already mentioned, evaluation data already mentioned, PEFT configuration already you have given, data field is the text, tokenizer, okay, you are taking sequence length is 2048. Okay, remove this packing and data set special tokens and append false. Nothing. बस ट्रेनर को कॉल कर दो यार, क्या है, ट्रेनर डॉट ट्रेन, ट्रेन कर देगा वो. फिर प्रिडिक्शन कर दो, मॉडल सेव कर दो, सेव द मॉडल एंड परफॉर्म द प्रिडिक्शन, प्रिडिक्ट टेस्ट मॉडल टोकनाइजर, ये कर दो आप. यू गॉट 87% एक्यूरेसी. ऐसे फाइन ट्यूनिंग करिए. ठीक है, ऑल राइट. यू हैव टू प्रैक्टिस फ्रॉम योर साइड. सी आई कैन एक्सप्लेन, मुझे मैं तो बता दूंगा, बता दिया मैंने पूरा. दैट्स व्हाट आई हैव एक्सप्लेन. द ओनली थिंग विद LLM इज यू गेट द परमिशन. ओके, गेट द परमिशन. अभी ये तो हैवी वाले हैं. एक काम करना आप, जस्ट डू वन थिंग, काइंडली फाइन ट्यून GPT-2. डोंट गो मोर अभी. ठीक है, आपको लामा तो आई एक्सप्लेन, GPT-2 का फाइन ट्यूनिंग ऐसे करना. दैट ऑल्सो यू हैव टू टेक इन द GPT-2. यू डोंट रिक्वायर दिस PEFT एंड LORA एंड द बिट्स एंड बाइट्स. नो, ये तो ईजी है. दिस इज ईजी. ओके, और अच्छा है तो भाई आप एक काम करो, और लोअर वर्जन बर्ट, बर्ट की फाइन ट्यूनिंग करो. ओके, बाय डायरेक्शनल इनकोडिंग रिप्रेजेंटेशन ट्रांसफॉर्मर, इसकी करो. क्या है, आसान है. सेंटिमेंट डेटा से देयर ऑल्सो यू डोंट हैव टू टेक ऑल दिस. बट अभी आपको लामा का मुझे बताना था, मैंने मेंशन करा था. ठीक है, तो बस आपको मॉडल लोड करना है, लोड द मॉडल एंड डिवाइड योर डेटा इनटू ट्रेनिंग टेस्टिंग एंड गिव द डेटा टू द मॉडल. दैट्स इट, खत्म. वो कर देगा ट्रेन. ओके. Fine. So that is from my side for this lecture. Okay, that's my side from this lecture. Let me